So for the next talk, we're going to move over to woody species and Zoe Harris from the University of Surrey.
Okay, good afternoon everybody. I am very privileged to have the last speaking spot of the day, aware that it's been a very long but excellent day for us. So hopefully we've still got you with us and keep you engaged for the last sort of 10 minutes before we break for the bar and dinner. So I'm Zoe Harris. I'm the Director of the Centre for Environment and Sustainability at the University of Surrey, and I lead the Taeda Tech project. So briefly, as you guys all know, we are funded by the Biomass Feedstock Innovation Programme. Thank you very much, Desnes. I want to sort of start by saying that this is the work of a fantastic set of people. I lead the project, but by no means is this my glory to have. This is to be shared with my wonderful team, many of whom are here today. So we have our project leads. You'll find a couple of these guys in the room. And then also the full team who do the work on the ground day to day, gathering and analysing all of our fantastic data. And very aware that sort of I was going to be speaking to you guys today, we've recently had a video made and it does an excellent job of explaining exactly what we do, and you get some great visuals. So I'm going to cheat slightly by showing you a video, and then I'll give you a little bit more juicy information afterwards. So hopefully this is going to work. Oh, partners, before I go into that, it's not just us again, we have wonderful partners, again, many of whom are in the room here today, who have been really helping us advance this innovation.
My name is Zoe Harris, and I'm a senior lecturer here at the University of Surrey. The Taeda Tech project is a demonstration project. It's funded by the Department for Energy Security and Net Zero. And the whole idea is for us to understand how we can increase the supply of biomass here in the UK. So the Committee for Climate Change estimates that we need 720,000 hectares of dedicated bioenergy crops by 2050. And we know that that won't be possible in the current time frame. Particularly, our project looks at how we can use aeroponics as a way of more rapidly increasing that biomass supply.
What Taeda Tech does, it takes aeroponics, which is a way of growing plants free of soil, and they're not immersed in water. We're literally just spraying them with this delicious nutrient mix. We've taken that, which has been done before on tiny plants, and now we're testing it on woody crops, on larger crops.
We're focusing predominantly on willow. This is a very popular bioenergy crop here in the UK because it grows very, very quickly.
I consider willow as a wonder crop because it has a lot of properties. We can use it as a bioenergy substance. It has the property to improve the health of the soil.
It's also fantastic for biodiversity, so it increases birds, mammals, insects in the environment when it is planted.
We are sitting on a site that about a year and a half ago, there was nothing on it. It was just a plain field. So generally a glass house would be maybe 3-4 meters. We needed something that would host our 4 or 5 meter tall crops. So we had to get everything custom built and designed for us.
We can do the cultivation in a very controlled environment where we can check temperature, we can control humidity, we can control the lights. And that helps us to grow our crops better, away from diseases. We can grow them out of the harsh weather condition.
We have learned that willow and the other trees that we are testing aeroponics on, they grow twice as fast when compared to the traditional way of growing. And we think we can get that even better. It's a process that we're working on. During the project, we have realized there's this great opportunity and a lot of interest in trying out different crops and different trees, which is what we are testing now.
We are very excited about the results we have seen so far with different species that we have tested, especially with alder and eucalyptus.
In this Taeda project, it's a multi-project involving a lot of different colleagues from different specialities. And we do a lot of computer modeling for this Taeda project, trying to describe how the plants are growing under different environment. So instead of experimenting everything, we try to use a model to help us to experiment less and more smartly.
we are collecting a lot of data, like the weather information, and those data will go into our model. So we can use our model to simulate the biomass growth of the willows in the aeroponic system. We also collect a lot of other data, which can help us to reduce the cost of the resource, like the fertilizer.
We're also modeling the socio-economic benefits of our aeroponic technology. The change of the products of the bioenergy sector impacts all the sectors.
So we're using life cycle assessments to compare growing willow in the field to growing it in the aeroponic systems, or using technology to understand which one is more sustainable. From the environmental studies, we are understanding that yes, by using technology, we are incurring greater impacts because we're using more electricity and water to grow the willow cuttings. But what we're also seeing is because we can put them in the ground that much quicker, we can grow more biomass sooner, we can bring the benefits of that biomass forward. And actually, we're seeing a net benefit by using the technology to do this.
This project started from a practical point of view of wanting to get more plants in the ground and addressing a particular bottleneck. And that meant that it had to go from the practical to the viable of actually getting them out to the field. And if it's going to be viable, then that means commercialization, ultimately in one form or another. When you're running a project like this, it takes many partners to make it work. There's a lot of partners on this project, from technology suppliers to the people who plant them out in the field for us for our field trials. We need to be able to establish that, what we do try, if it works, there has to be an end market. Otherwise, it's just research for its own sake. And I think people who can help us identify and quantify those end markets is something that we're really actively looking for right now.
It's been a really exciting journey. When we started, we had nothing but an idea and an Excel spreadsheet with some lines in it. And what we have now is this amazing site. We've demonstrated that the plants grow well in aeroponics, and we have an amazing team with such a wide array of expertise. So we're really excited about what's going to happen next.
The way forward, we feel, for our technology is to get policy support for this space, not only for biomass crops, but also for controlled environment agriculture as is. The other part of the picture is also gaining investment for this technology. Where its application is so diverse, we think there's a lot of opportunity for many industries to benefit from it. So things like research, where we understand how crops grow, looking at medicinal crops, how can we create biopharmaceuticals, things like food, and also other kinds of forestry species. So we're really excited to hopefully start some new partnerships and look where we can have real impacts on society.
So hopefully that gives you sort of a big, broad brush overview of what we're trying to achieve in the Taeda project and some of the really diverse aspects and approaches we're taking. Pretty much everybody you saw in that video, most of them are in the room, I think except 2 or 3. So please do come and speak to us if any of those specific areas were of interest. But as we summarised, we have found that we are able to cultivate faster, on a smaller footprint with a higher yield, with a higher degree of quality control, which we believe is giving us a superior product at the end. So I just want to give you, just ending off my talk, is just giving you some of the more kind of nerdy science underneath it for those of scientists who put their hands up earlier. So we've looked at field trials. We need to validate this growth method, and this is the gorgeous Will McAlpine modelling here in our photos, demonstrating our growth. And so you can see there on the right our aeroponically multiplied willow and then our conventionally multiplied material. And based on initial findings, we are seeing some superior performance. We need more data to underpin this, but we think this is really, really promising. We also mentioned that there are other crops, so you heard the mention of alder and eucalyptus. We are looking at other markets because, as we know, bioenergy is a bit challenging at the minute. Without the kind of the markets there. So we are looking where we can expand the application and benefits of this technology. And this is just an example of some of the studies that we've been doing. This has been led by Lekan. So you can see there that our control crops are performing more poorly compared to our aeroponically multiplied. So we are able to get them again to a commercial spec in a much shorter space of time. We are also looking at how we can make better decisions in our system, so how can we optimise our environment. and we are doing that using a digital twin model. So this is about essentially modelling the environment we're working in, taking lots of measurements, lots of data to simulate our environment within the computer, and that then helps us make better choices in terms of how we manage, predicting yields and also predicting and reducing those inputs ultimately. We then have the question of, is it sustainable? James is here, he touched briefly on it. He's our life cycle assessment expert. We want to understand how, by using potentially a little bit more energy initially, we might end up with gains by accelerating our way forward. And what we found, and this is just a very quick graph with total global warming potential, is that we do have a means to be better than traditionally multiplied by the fact that if we can get this feedstock ready quicker and plant it sooner, we can be meeting our carbon targets sooner than forecasted. And then finally, we have these wider benefits. So what will this technology and what will the products of this technology offer the UK in terms of societal and environmental economic benefits? And again, some very preliminary outputs. We can see that we do see direct impacts on GDP. We do see the opportunity to export both the crops that we are generating, but also the knowledge and the technology itself. So I will leave it there. I'll say if anybody has any great ideas, we would love to hear from you. We're very, very keen to collaborate. As I said, we're working with many people in the room already. We'd love to expand our reach. We are on the socials, so do feel free to follow us on LinkedIn or X. And I think that's it. Thank you.